Good day guys, welcome back to my channel, and in today's video we'll be discussing basic exponent rules or the basic rules of indices. Now knowing those basic rules of indices, I doubt if there's any question you find it difficult to solve. Once you master these basic rules and you know how to implement and interpret them, then definitely solving equation that involve indices or logarithm will be very easy for you. Now those basic rules are more than 4. There are actually some textbook break them down into 4 places, while some further splitted those 4 basic rules into some of 10 or 12, but in this video we splitted them into some. So in this video we are going to be introducing the rules and we give example. Whichever rule we explain, then we give example to make it clearer. Now the first basic rule, which is rule number 1, is the rule that talk about what the power 0. So anything that is carrying the power of 0 is 1. So here we have x to the power of 0 is 1. Looking at the example, we have 3 to the power of 0 is 1. And the next rule is when an unknown is carried to the power of 1. So it means where we have what x to the power of 1 is still the same thing as x. While for the example, we have 9 to the power of 1, which is same as 9. Then the third rule is also known as the product rule. Now whenever the bases are the same and you are multiplying the bases that are the same, then it means you add the powers, right? This is what the product rule. So I have x to the power of a times x to the power of b. Now since the two bases are the same, I will pick one, which is x, then I will add what the powers, which are what a plus b. Now the example that we give is what x to the power of 3 multiplied by x to the power of 5. Then we have x to the power of 3 plus 5, which should give us 8. And now the next rule is quotient rule, or you call it what division. Now we have x to the power of a divided by x to the power of b. Now since the two bases are the same, then it means I can pick one of the base, then I will subtract what the powers. So it means if I have x to the power of a divided by x to the power of b is the same as what x to the power of what a minus b. Now a is positive because it's the numerator, while b is negative because it's the denominator. So it means the one that is on top, which is the numerator, will always be positive, while the one that is used to divide, which is what the denominator, will remain negative. That's why I have what a minus b. And the example we have here, we have x to the power of 11 divided by x to the power of 4. Now it means that we have x to the power of what 11 minus 4, and 11 minus 4 will give us 7. Then the next is if a sub product rule. However, for this sub, what you are multiplying is the powers. You are multiplying the powers. In this sub product, you are multiplying the powers. Then it means we have x to the power of what a to the power of b. You are having what 2 powers. Now since it's product that is combining them, then it means I can have what. Now since you are multiplying them, then it means this is as simple as what x to the power of what a multiplied by b, because both a and b are what are powers, and it's multiplication that is binding them. And the example we have is this, which is x to the power of 5 is multiplied by what another power 3. Then it means we have x to the power of what 5 multiplied by 3, which should give me x to the power of what 15. Then the next rule is xy to the power of a. Now you have two products, you have two bases that are carrying what a single power, and these two bases are combined within a bracket. Then definitely it means each of the base is carrying that power. So if we have x to to the power of xy to the power of a is same as what? X to the power of a multiplied by what? Y to the power of a. And the example we have here, we have x y to the power of 4, then it means the same as what? X to the power of 4 multiplied by what? Y to the power of 4. Then the next rule is, here we have a quotient. We have x all over y all to the power of what? A. Then this is same as what? X to the power of a divided by y to the power of a. And the example we have here, is x all over y to the power of 6, which is same as what? X to the power of 6 divided by y to the power of 6. The next example is the inverse law, where we have x to the power of what? Minus 1 is same as what? 1 all over x. Right now, this negative sign is what is bringing this division. So it means we have what? 1 all over x, then to the power of what? This here, which is this one. So it means it's what? X to the power of 1. So the reason why I have 1 all over x is because of this negative, right? Because of this negative, I have what? 1 all over x. Why x is carrying this as a power, and x to the power of 1 is x. That's why we are not seeing anything there. Now the example is what? 3 to the power of what? Inverse 1, which is what? 1 all over 3. Also, I wish for instance it was 3 inverse minus 2, then it means it should be 1 all over, as a result of this negative, then we have 3 to the power of what? 2. However, this is 1, that is why I have what? 3 to the power of what? 1. And the next rule, okay, now we know the previous one we make use of 1, then we decided to use minus a so that it will be clearer. So here it means we have x to the power of what? Minus a, which is same as what? 1 all over x to the power of e, right? Don't forget this division sign is coming, or 1 all over our base is coming because of what? This negative power. A good example is what? 9 to the power of what? Minus 2, which is what? Same as what? 1 all over 9 square, and 9 square is 81. Then the next rule is your index is having a division, is having a fraction, right? Your index is having a fraction. Now whenever your index is having a fraction just like this, where we have x to the power of what? 1 all over n, then it means this power here, the numerator will form the power, while this denominator will form the index of the root, right? We form the index of the root. So we have x to the power of what? 1 all over n. So this numerator will come to the power of your x, then you have root, right? The denominator will form what? The power of what? The root. And a good example of that is what? X to the power of what? 1 all over 3, where we have, since it's 1 all over 3, then it means this 3 will form what? A cube root of x to the power of what? 1. Then the next law is just like the previous one, but we decided to explain it further by using what? M and n. Now it means here we have what? X to the power of what? M divided by n, which is still what? Power quotient law. Now your m, which is the numerator, will come in form of power, while the n will come what? In form of what? The root, which is the denominator. So this is same as this. So it's either you write it like this or you write it like this. So a good example for that is what? X to the power of what? 9 all over 2, which equals, this will form the root, and this numerator will form what? The power. Alright, so here is supposed to be our power of 9, not n. These are the basic rules that we have for indices or exponents. Thanks for watching, and don't forget to subscribe and share this video for others to benefit. Bye and have a nice day.